Hi.
Any man's life will be filled with constant and unexpected encouragement if he makes up his mind to do his level best each day. With the same zeal and enthusiasm, on behalf of Amaljodi College of Engineering, I welcome you all to the STTP on Paradigm Shift in Assessment and Evaluation Practices for Engineering Graduates. I now request the course coordinator, Dr. Therese Yamuna Mahesh, to introduce our resource person, Sri Harindralal Gangadharan, for giving us a thought-provoking talk on the topic From Principles to Practice, the Journey Ahead.
Good morning, dear participants. Let me introduce to you a person who is passionate in imparting knowledge to the community, spreading information about conservation of energy, environment, and renewable energy sources. Sri Harindralal AG did his graduation and post-graduation in College of Engineering, Trivandrum, and qualified in MSc Electrical Engineering in the year 1971. His professional associations include Life Senior Member of IEEE for a period of 38 years, Chairman IEEE LMAG Kerala Section during the period 2018 and 19, Chairman IEEE PES Kerala Chapter during 2016 and 17, Founder Chairman of IEEE PES UAE Chapter 2002 to 2005. The awards conferred on him during the last 3 years include Outstanding IEEE PS Chapter Award and Life Member Award in the year 2017, IEEE Council Volunteer Award in the year 2018, and IEEE Region 10 Life Member Award in the year 2020. His expertise include computer-aided planning and design of electrical system on the utility side and the computer-aided design of electrical systems after the meter. Currently, he is working as director of Ananda Ganga Institute of Engineers. His previous assignments included General Manager, Design Electrical at Hijol Techno Consultancy Private Limited, Senior Consultants, Sumanam Engineering Services Private Limited, Electrical Team Leader at Mauchel, and a lot more. Currently, in his capacity as Chair, Inter-Society Activities Committee of IEEE Kerala Section, he has been organizing weekly webinar series at 6 to 7 p.m. on Wednesdays since 15th April 2020. You can see him on the screen with very interesting topics from eminent personalities. Today, we will hear him on the topic From Principles to Practice, the Journey Ahead. Over to you, sir.
Good day to all. Thank you, Professor Therese, for the wonderful introduction.
Thank you, sir.
At the outset, let me excuse me, please, 1 minute. Sorry for that. I forgot to switch off my mobile. Sure. Let me thank Professor Teresa, the organizers of this program, the department of the faculty members of this college, the management of the college, the main sponsor of the event, AICTE. And I consider it an honor and privilege to be invited over here to give a talk on this very august audience. A good day to all, once again. I hope you can.
Sir, could you keep your mic a bit more nearer?
Can't hear it.
Yeah, it's
Okay. No problem.
okay, sir.
Is it okay now?
Yes, sir.
Am I audible?
Yes, sir.
Yeah. From principles to practice, the journey ahead. Are you familiar with this picture? He is none other than the person who has devised the Tesla car, SpaceX, Elon Musk. He is one of the modern innovators of this period, who has made many innovations. A very good example from for the principles to practice. This is one of his another innovations, Hyperloop. You must be familiar with this one. Hyperloop is the greatest innovation in 100 years, or a road to nowhere, this is called. It was introduced in 2018 in a research paper as a fifth mode of transport after planes, trains, cars, and boats. This is Kolam from Trivandrum. This is car park from Calicut. It will take only half an hour from Kolam to car park if you travel by the Hyperloop in 30 minutes. Artificial intelligence can transform the homes around the world and our way of living with it. Robotics is revolutionizing factory operations. Self-driven cars can make driving a thing of the past.
ഓഫീസ് ഞാൻ അറിഞ്ഞില്ല
It's a cryo-electron microscope with data analytics, high performance computer, deep learning are employed to fight the pandemic. This is a picture of a virus taken from cryogenic electron microscope. You can see on the left the resolution before 2013 and right on the 2000 the current resolution by the cryogenic electron microscope, through which you can see the structure of the virus and how the drugs operate on that can be viewed this one. And this is leading a great way into the discovery of the antidote for the virus. Is our education system capable of coping with such drastic transformation of technology? Are our students equipped to take up these challenges? This is a report. This is a part of the report from the Aspiring Minds National Employability Report in 2019. The employability of Indian engineers continues to be painfully low, with more than 80% engineers unemployable for any job in the knowledge economy. It's a very pathetic picture now we are in. They also says the employability of Indian engineers has not changed on an aggregate level since 2010, and they call it the stubborn unemployability. Who is behind this? Whose stubbornness is behind this stubborn unemployability? Whose arrogance is behind this stubborn unemployability? We have to think about that in a great way. Another part of their report, only 3.84% of engineers are employable in software-related jobs at startups. Only around 3% engineers possess skills in artificial intelligence, machine learning, data engineering, and mobile technologies. And on an aggregate level, employability in these areas is around 1.5 to 1.7%. US has a much higher proportion of engineers, almost 4 times, who have good programming skills as compared to India. 37.7% of Indian engineers cannot write an error-free code as compared to 10.35% of Chinese engineers. Yet another observation, only 40% of engineering graduates end up doing internship and 36% do any projects beyond coursework. But there were sporadic attempts to make amends to the state here and there, but not any bold steps taken so far. I can cite you several examples. NEP 2020, the latest one, aims at increase in gross enrollment ratio to at least 50% by 2035. That's a good thing. You have to increase the gross enrollment ratio of the country. That's a good thing. But is it sufficient? You can see what is the gross enrollment ratio is. This is the gross GER for the higher secondary education, the equation, the formula, the total enrollment in higher secondary education, regardless of age, divided by the eligible official higher secondary school age population in a given school year. So, by increasing the GER, you can increase the number of intakes. This is the GER for the last 5 years, 2014 24.3 to 2018 26.3. It's a very gradual step. For that, that's a good aim, as which you have in NAP has proposed. This is the current GER, the state-wise GER. But GER is a very weak and narrow indicator of education performance when seen in the light of rapidly changing industry trends. My worry is NEP does not make a point on this issue still now, even in 2020, even after 73 years of independence. Many education policy has come. This has come after a few years from the last one, with many thoughts and behind that. Enrolling more students in institutes seem irrelevant if they are not being provided skills that are commensurate with their charging times. The curriculum that is offered by the institutes of higher education in India is hardly keep pace with the industry demands. There is an urgent need to shift from input-based indicators of educational progress like GER, which NAP 20 has highlighted, to an outcome-based approach. But the outcome-based approach proposed for the outcome-based education is very vague. The targets fixed in this outcome-based education is very vague. The education institutions, the management, even the universities can play with it for at their will and pressure, which they have been doing for the last many years, and they are let alone let off the hook to do it on their way. Where we are proceeding with this state of affairs. Outcome of graduates coming out of the college is to be evaluated based on their level of employability. The outcome measures also need to expand their scope beyond the anti-grade job. Institutes to be encouraged to impart a holistic understanding skill that will be required for a lifelong career. This is a part of the Manual of Accreditation of Undergraduate Engineering Program. The number of faculty members must be educated so as to enable them interaction with industrial and professional practitioners. It has clearly mentioned the Manual of Accreditation. But how many of them are how many of the institutions are practicing this work? How many universities are practicing this work? 1.5 million students are coming out of the college per year in India. If you go to the syllabus of the colleges, Let us take the syllabus of KTU itself. The syllabus is more on the research side, oriented for research side, not giving consideration to the practices. The academic community does not usually proactively seek industry input. I have been contacted by half a dozen colleges to be their professor adjunct. But after that, there's no call. Maybe they are using my name so that they have a industry cooperation. So that's the trend we have been going on. There must be we might have to put some end to that. There must be some concrete proposal, concrete guidelines put forward. Every institution has to achieve this one. Otherwise, what we have been following should go, and the unemployment rate, we have to say after 5 years, from 2015, we are having unemployment rate. That will be a trend. Most colleges and universities have industry advisory committees. But in my experience, school pays only minimal attention to what these advisors here want. So this is what I say initially, the arrogance. There is an overall attitude of we are smart. I know what is best to teach. Maybe to an extent this is true. This is a sample of the PEO of some of the colleges. This is a PEO of a CET. I have gone through the PEO of many of those. I have taken a sample of 4 of them of different. No word is mentioned about the industry affiliation in the CET, the leading engineering college of Kerala, where after IIT and NIT, the cream is rushing over there. They have a good result. And they are the people who are leading for the implementation or the modification of syllabus. To them, almost, I will say 100%. 100% of the students are going for higher studies or some other. They will be getting good campus selection, and some other service examination, bank examination. They are going like that. So practically none will be coming from their college to the local industry, and they are not worried. It's not it is not wonder, because it is not concerned to them. But they must understand that the several engineering, the 160 odd engineering colleges minting out engineers every year, not at all exposed to what is needed in the industry. And whenever we discuss with them, they pay little attention to that. Is there a single word of PEO, I say industry PEO of the CET? This is much better. The PEO of PKM, practicing the electrical technology has to excel as a practitioner engineering professional to meet the challenges industrial academy. At least they have mentioned that, and I know that they are doing some work on that also. This is the PEO of Amaljoy. They have made a higher responsive industry, and they have one eBay module here. That's a good sign. But with gaining a eBay module, they will not rest on that. They have to see that it is properly implemented and there is proper goals are achieved. Periodical monitoring is required there. And this is the PEO of Marine Trivandrum, Marine Engineering College. They have mentioned some words about the industry in some of their points. And they too are doing something. I don't say much. They too are doing something on this industry side. Because being a part of the IEEE and the chairman of the PES for the for 2 years from 2016 and 17, and later chairman of the Life Member Affinity Group 18 and 19. I have been traveling from the length and breadth of the country, spreading the importance of imparting knowledge to the people, and for the industrial association. We have made a, in 2017, when I was the chairman of the Power and Energy Society chapter, we have made a move with the electricity board. We identified 30 problems of the electricity board and discussed with the leading engineering colleges, and they were very happy to take up that. But there were some problems with the electricity board also. When we came back, the management said, the new chairman said, he was not interested to follow it up. So we could continue that. And later on, I have to move away from that role. Now they are doing some work on that. That is what I understand. This is a draft NEP 2019. It is mentioned that technical education faces specific challenges as these disciplines are neither entirely knowledge-based nor as they entirely skill-based. There will be great need for closer collaboration between industry and the institution. Accreditation shall incentivize in collaboration with industry, faculty, the industry experience, enhance internship opportunity. Very well written, given the specific clear-cut guidance on that. But what happened when it came to the actual policy? It's been diluted. I don't know what is happening to our country. What is happening to the industry, the education, the so-called educationists and the policy makers. They don't see. That is what the aspiring minds has said. Obstinate unemployment. This is the obstinacy of the so-called educationists and the policy makers, which make our country in a worse state. Lack of education. The engineering college mushrooming across the country. That's the main reason. When I'm sorry to say these things. I'm sorry to be frank also, but I don't feel sorry to be frank. But before a community of mostly of the academia field, from the I will say from the receiving end of what I say. But this is we know that truth is bitter. So we have to take that bitter truth with some sugar. That's the only way we can escape from this one. But the self-financing college has come. I think that's one of the biggest blunder those regime has committed in their life. And they let loose, and many people have jumped into the wagon for making money. They have shifted their business from other they have been doing to the college. And what was the idea they said? Many people are going to Tamil Nadu and Karnataka for higher engineering college education. Why not we have here? And we have the benefit here. But what did they do? Without basic structure, and they have sanctioned the colleges. And I will say there was connivance from the AICTE also to get it approved. Most private colleges charge great amount of capitation fee. It's not a secret. Everybody knows that. And they enroll students, then mass, then educate system of non-training college education. And without exposure to practical challenges. And that is what I say, AICTE has connived with this one. And this is one of the greatest jokes of all time. For engineering, studying engineering, no minimum marks is required. I still remember years back, one of the leading leaders of the self-financing college committee, I said, why should we have maths? Maths can be no requirement for math. So the government has reduced the minimum marks for the for maths in the entrance examination. And what is the status? Without knowing the simple mathematics, school level mathematics, they are coming to study engineering college. How they will fare there? It's no wonder they will fail in the exam. And what will happen after that? After 4 years, most of them are coming, or many of them are coming out with a basket full of supplies in their head. And their life has gone. And they are doing some other job. This is academic performance index for 2016-20 of AICTE. Released on last October 1st. Only 6 colleges has got the maximum. They got six points, and the majority of them, 41 numbers are there in the grade 3, 42 numbers are in the grade 2, got the index 2. What the policy makers are doing for this one? What did they do to solve these things? It's a cumulative count. Only 26% of the college, out of the 160 odd colleges, 17 got more than 4 points. It's a very pathetic sign. Very pathetic sign. I don't know when we are getting out of this. This is the trend of our youth. India is a country of youth. 50% of the population is below age of 25, and 65% is below 35. In 2020, the average age of 19 is 29 years. Very young age, very young bird. And they are coming with a lot of enthusiasm. If they are providing with enough input, the country will where will the country will reach anywhere. It can outshine any country in the world. But what they are doing, what the policy makers and educators are doing with this is very pathetic and sad side. Compared to in China it is 37, in Japan it is 40, and we have 29. Let's see this position. Engineering colleges, even IITs, do not rank top in the world. The curriculum followed in many of the streams, such as in the case of software engineering, is still outdated. Recently, I had a talk from one of the leading education system of Kerala itself. We will train the basic knowledge required for the engineer, but we can't train for the industry. Then who will train for the industry? Computer systems and software development is a dynamic field which demands constant adaptation to changes, something that our education fails to reach. Not only are software professionals taught outdated programming languages, our engineers are asked to study our old engineering and production techniques. This is another field, internship. It's a good thing if implemented properly. My point is, every student should be made to apply for internship from the first year itself. Not only in Kerala, not only in India, but worldwide. That's the policy. Though internship has been following, we have been following internship for many years. Even the faculty has taken it in a very light way. They have sent them, and what they were learning from them, nobody is bothered about. I am from an electrical engineering stream. I was a member of the Kerala State Electricity Board, and I left KSC Board in '93, and I was an executive engineer. I could do a lot of things there and during this period. Thanks to my association with IEEE and my professionals there. Unfortunately, in electrical engineering, there is no industry. Very few industries which absorb the students within the country, within the state, the electrical students. What they are doing? Sitting to the electricity board. What for? I will say that's a big zero. They will not learn anything there. Nobody is there to teach them. I don't know, very pathetic incidents happening in the electricity board. They are made to do photocopying. Very pathetic site. They don't understand why they are sent. But I am not going to blame the electricity board. Not because I was from the electricity board, but it's a duty of the university, colleges, and see that when the students are sent to them, they are given some, some knowledge has to be imparted to them. Without this knowledge, what is they are spending another 2 weeks or 3 weeks without any aim. So this should be changed. That's what one of my point is. Internship should start from the year one. Every student should be asked to get internship locally, like in Kerala, in India, or even abroad. Let them contact different persons. It's not an easy job, but let them do it. There's another point I want to impress upon you. There must be internship for the faculty also. The period that can be determined, I will say minimum 6 months. They will understand what is happening in the industry. Now, none of them know anything. I will say none of them means the only infinitesimal percentage of them is knowing about that. Maybe they might have worked in the electricity board or in the industry before joining the academia. Other don't care about those things, because our educational structure is for the aim for the research work. That is the shape of our curriculum, the syllabuses. After post graduation, they are studying in the top colleges. They will be getting some gold ranks, gold medals, etc. Going to IITs for their higher study, getting gold medals from there, and coming back to engineering colleges, and they will be leading the academia field. They don't have any industry background. They don't require industry background. This is only for the research purpose. So this is what is happening. This has been happening in this one. Still, this will be going to happen. That's my worry. And they don't want to interfere with the or interact with the industry. And unfortunately, the reverse is also true. Industry also does not want to interact with the academia. They are in the two watery compartments, academia and industry. We have, as an IEEE, I have some limitations also. We made some effort to have some academia and industry interaction, but that is to be carried through. Who has to take this initiative? The policymakers, the educationists, the universities, etc. has to make the initiative. And there are forum of the industries also, industrial forums also there. Let them have some discussion. Go ahead with that. Only with this internship of the faculty, the knowledge partnering will occur. They can go to the industry. They can understand what is being taught. They can understand what is the problem they are facing. They can take up these problems rather than taking problems in the PhD without any use. Study some problem which is useful for society and make some results. This will be benefiting both the industry and academia. But who is going to belt the cat? This is a complementary. academia, industry is a complementary business. Both are going to gain in this. It's a win-win situation. But here, nobody is scared about this thing. They are bothered about many other things. This is the least thing they are bothered. So with the knowledge alone, the students will not be benefited. We have to provide them the skill and the attitude. Some steps has to be taken to provide skill and attitude. If the internship is done properly, that's a good idea. Every year, send them to any industry. Say 2 weeks, 3 weeks, they will be getting a lot of skills from there. Their attitude will be also be changing. So that will lead to competency, which is needed in the for the employees once they go out of the college, by the society. These are the 4 pillars of education: student, faculty, management, industry. With these 4 pillars, without these 4 pillars, it will collapse. No doubt, it has been collapsing. But without industry, there are 3 pillars. There can be some stability with that. But if once it is designed for a 4-pillar structure, the 3 pillars will not work. It will fail. If it is designed for a 3-pillar structure, okay, that's a stable thing. But if it is designed for a 4-pillar structure, there must be 4 pillars. If 1 pillar is gone, the whole structure will go. And this is the problem with the industry, the academia we are facing. One pillar is missing. Now I will have a small break. If there are any questions, we can discuss. The second part is I am providing something from my personal experience to you, mostly useful for the electrical engineers. But these are not rocket science. Any person with some basic knowledge, P power is equal to voltage and current, can understand these things. I request those who are not even in the electrical stream can understand this one, and they can impart their knowledge to their counterparts in the institute, in the electrical department, and they can take up this thing, and thereby they can increase the skills of the students. The employability of the students will be improved. I don't have any expectation from the university that this will be implemented in their future. I have discussed with many persons. I have personally known them because of my association with AICTE. Because there is a barrier. I know there is a barrier. I felt that barrier. That is what I mentioned earlier. I'm not repeating that word. We will understand what is required for the society or the country. Okay, we will have a small break. Are there any questions?
So, participants have posted some questions.
Okay.
Shall I read that out to you?
Please.
Private institutions charge extra based on the demand of the course, and they pay low salary to faculties. How to correct this? Is there any solution?
No, this is what is happened. I told you, I have an experience. I have been traveling from as an IEEE office bearer of the Power Engineering Society and Life International Group, traveling from the length and the country, visited more than 25 colleges, conducted the program which I want to show it to you in different colleges. Unfortunately, one faculty will be coming there to make me happy, and after some time he will go. He will not be there. They are not interested in that. Maybe my teaching may not be that okay with them, but at least they should understand what is being taught. and they can modify it and the teaching techniques and give it to their students. Where the employability of the students can be improved, but they don't understand the importance also. That's a very sad state of affairs. When I met one of the colleges in the northern part, now they are recruiting more PhD scholars in their faculty. But what happened to them? Because in the initial trust for the making money, the staff were, as you said, those who are coming out of the college were recruited. They paid less salary because they are also happy coming out of the college. They are getting some money. And if you want to get good money, you have to pay more. There's an old saying in the HR: if you pay peanut, shall I repeat the other word? You will get monkeys. So that may happen. They don't understand that because they are not in this field. Their field is separate. They have been making money in other fields. They thought that this is another field of making money. Now they understand that they have made a mistake. Why? No students are coming. How their students are coming? If I want to send my son or daughter, my child to a student college, I will check up what is their how is their faculty, how was their past records in the results. Will I send my child to them if their records are poor, the faculty are poor? But they are improving their faculty, but still their records are poor. Why? The students with less marks and no marks in maths join the college, and how they will fare in the college? The academic performance index will be low. Will they get any person? Even if they give recruit more PhD scholars in their academic in their faculty, they are in a vicious trap. That's what happened. They did not understand when they committed this mistake initially. Normally they will not do it. It's a government who has to make the gates and norms. I will say they are worse than those people who has made this money. I'm sorry to say that. One of the biggest blunders those persons has committed in their life, sanctioning the self-financing college without any proper guidance, without any proper checks and balances. Because there are politics involved. Politics always immersed in money. Everybody knows this. I don't want to tell this out. Everybody knows these things. When I say it aloud, everybody will come on my head. But that we have been seeing this one. We can't criticize anything in this system. If you are criticized, then there will be hue and cry. I don't bother at this end of my career and life. Anyway, we have lived a life. Anyway, we have to end our life. One day I also end my life. That's all. So that's a fact. I don't have any solution. Only the government has to make some norms, or they have spent a lot of money, made big mansions for the colleges, and actually this money should have been spent so far. The other businesses have minted money from there, but they were not knowing what to do. They thought this was another money making business. Actually, government should have made some stipulations for that. And who else to make the stipulation? You and me can do that. And that is what I said. That's what I said. The biggest blunder those ministers or a minister committed in his life. So I don't have any panacea for that. Since we have to live with that until the policy makers listen to these things. I don't know whether I am sure this will be my talk will be heard. There will be a noise in the wilderness. Nobody will listen to it. I am very sure of that. I'm sorry for that. For the question. Question is a very good question. I know that has come from the bottom of their heart. Yeah.
Sir, we have one more question for the time being.
Okay.
How do we effectively bridge gap between industry and academia?
Yes, I have rightly said. There must be the internship. We have to start from every year, 2 weeks, 3 weeks every year. All the students should be sent to the industry or the other parts to learn from them. And the academia, the internship for the academia. And there must be some academy. We have to break the barrier academia industry interaction. That we have to open that watertight compartment. Let it be merged together. It's a complementary thing. Both of you are going to gain from this. If they are not coming, you go. If the mountain is not coming, let the prophet go to the mountain. In a little way, I have made some effort. That was successful, but I'm sorry I could not continue that because it was beyond my reach. When I went back to the university board for the follow-up, that time the old chairman went, who was giving us a lot of support. The new chairman came. It was not at all interesting. That's what happened. What we can do. But the problem is with the colleges. They could have taken up, made some studies, and made some reports, and sent to me, or sent to IEEE, or sent to the RCT board. No, I don't know what happened. I don't know what happened. Because of maybe that work there at that time, because our personal interventions. Okay.
So we have more questions coming in. Would you like to take a break or?
No, it's okay.
Okay, sir. Will interface between industry and academic ever happen under COVID-19 conditions where education delivery is completely disrupted?
In the COVID situation, we have to think about how effectively that can be done. But COVID came only now. It's only maybe for I don't think there will be any release before 2020. But let's think about this future. For me, I am not an expert on this, but I feel this 2020 should have been a 0 year. Everything should be stopped. Now we are let loose. I don't know what will happen. That's my feeling, and I have shared this feeling with me. Somebody has also shared with me. I don't know how far. I cannot predict. I cannot. I am not an astrologer. What will happen? This is what I have felt me. There are so many people who are difficult to earn their living. So that it cannot be a 0 year for them. But the government should see how they have to be met. When money, they have to, where the money comes, I don't know. But life is more important. Life is more important. We have to give more importance to that. We know what happened. When I say this one, I will be stepping to somebody's shoes also. I'm sorry to say that. But we have been in a very controlled situation initially. Everybody was applauding Kerala for a good control of the situation. But what happened? Let loose, and nobody cares. And the people also. I blame the people also. But The government shall enforce rules. To enforce rules, then only this can be done. Without enforcing rules, nobody can do that. We have many instances what happened. Without enforcing rules, do we follow this thing? Nobody will follow it. But that is the state of our country. Or at least I will say for the state, when there is a law came for the helmets, there was total opposition for that. For saving their helmet, it is my business. Is it my business to save his helmet, his head? Nobody is cared about that. Nobody. That's a sad status of our people here. I'm sorry to say that. That is what my feeling. That's my feeling. Don't say I'm a cynic. Don't say I'm not a cynic. I observe these things and I make very little observations loudly. Because the opportunity came, I thought I shall share my feel. That's all. Okay. So COVID will go. We have to think about, or we have to think about what can be done during the COVID. But COVID, after COVID, what we have to do? COVID is not the end of our world. Every maximum it will be 2 years. What will happen after in 2022? We can plan this one now. We can plan this one. That's what I said. It can be 0 year. We can plan a lot of things for the future. We will start from the scratch for the better of the country. In other words, anyway, COVID has come. We have to face the problems, but not at the expense of the death of our citizens. Definitely not. I don't accept that. We have to tighten our belt. We have to tighten our belt and share this thing with others also. Okay then. Thank you for not giving any concrete suggestions.
The next question: what changes should be brought about in the industry internships to make it effective?
There must be interaction with the industry and the university, and we have to sit with them. See, we will send their students to you. You have to train them. Tell them frankly, very frankly. They will also, because they are not getting anything from out of that. But they have to be convinced that we are doing for the purpose of the country. That we are doing many things for the country, not for anything is not cannot be done for loss and profit basis. We have to sit with the industry, and we will be sending students 2 to 3 weeks a year. How much you can absorb, and how can you train them? But you have totally absorbing them. They have to train them. This should be taken at the government level, and then only solved. Or if any college wants, they can go to some college, some utilities or some industries, have some discussion with them. We do not wait for the university or government to do that. So some we have to break this, and I will say this is in the long run, not only the country, it's going to the institute and the particular industry is going to benefit out of this. I am very much sure that this interaction is required. The academia industry interaction is required for both the academia and the industry, and they will also understand later. Because somebody has to tell them this is good for you. Why don't we accept that? They are also making open the industry for making money. They think if I spend some money, some time for this one, what is my benefit? They will think in that way initially. But we have to make them think the other ways also. This is a long run, it is good for them and good for society, good for the country. And let them do something for the country. And at the but definitely they will reach benefits out of this. I'm 100% sure of that. Okay.
Sir,
Yeah.
can virtual online internships ever replace real-time internship in terms of exposure?
Very difficult. Very difficult. Only some areas, maybe in software areas or some areas, I don't know. Other fields, software areas you can try, no problem. And some areas you can try. Some areas not. Some areas you have to go there. But but we can have some interaction. What's the interaction we can have? Let them give their initially. Let them have some interaction. Let them give their problems. You study the problems and make some solutions. Make the path clear. You open the path. Make the path clear. Then that can work out wonders. Yeah.
So that's with the questions that we have right now.
Okay. Okay.
Okay, sir.
Give me 2 minutes. I will be
Okay,
back
sir.
within 2 minutes.
Okay, sir.
And I will continue the rest of the session.
Okay, sir.
What's time now? By
It's
11. By 11, I will be here.
okay, sir. Participants, you can be back at 11 as sir is taking a short break. Sir,
Yeah.
are we resuming?
Yeah.
This okay.
I'm okay.
Okay, sir.
Welcome back. Thank you for the patient listening. I will share with you one experience of a very leading scientist from India. He's from Kerala. Yeah, everybody knows him. Dr. M.S. Panikar. A couple of years ago, while he was receiving one award, Wakamovi Foundation Trust Award in Anthem, he gave a speech on that award, and he shared an experience he had while he was returning from abroad. He thought he will go to some institutes, academia, and have some feel from there before joining the other area where he was interested. Maybe he was on his way to Sri Lanka. I am not sure. Anyway, he's coming from abroad, returning from abroad. And he went to one of the IITs. And he was in one corner. He has been doing some work. After some time, one of the professors asked him, "What are you aiming at?" He said, "I am in the process of how to make hardware." Hearing the answer of that person and what he narrated, I felt also, how can a IIT professor say like that? What? And MS Malikan should not need not tell lies on that case. Why should he? He said, "No, this is only a technician job. Why don't you do some other research work?" And they think the research is not making hardware. It's only some multi-degree equations has to be solved. Then only something can be made. So I have felt this, not from the IIT, from local engineering college, this attitude. I have prepared a paper on what I am going to present to you and show to many people. And I know them personally well also through my associates with IEEE. But none of them were impressed. Because there was no references for them. Actually, there is no reference. There is no reference. How can I put the reference? So they are going the regular stream of reviewing papers for conferences. How many references are there? How many peer reviews are there? Like that. So I don't have any reference. I don't have. I actually, after that, I tried to go to the net and search for references. I could not find any. Maybe my limitation. I don't know. Always they could have made some. I left it there, but they did not understand the importance of that also. That's what I want to say. I don't know how many of you understand the importance of that. Okay. As I said, I was in the electricity utility from 1972 to 1993. In 1992, I was the IEEE section there. I mean, I forgot to mention. I said I should say that also. And I think that was a major contribution from me. And then I went abroad. I was in the power utility there. From 1987 to 2007, from both, I worked in 3 utilities, one in SAD and the other 2 utilities abroad. I have been doing computer design of planning and computer design, planning and design of electric systems on the utility side. In 2007, I left the power utility there and joined the international consultants, an infrastructure consultant. One of my first job was the designing of the first smart city in the world, smart city Malta. Then we got the smart city of Cochin also, did not complete that because you know what happened to smart city Cochin during that period. Then I left that place and came back to India. I joined some consultants. So that 2008, I started my association with the other part of the power system. Previously, it was the utility side. Now on the consumer side, I will say on after the meter. So many students was coming to us after their graduation for job. When I interviewed them, I felt that something lacking in their syllabus. Because most of them were from CET itself. So not because the students are bad, they have good records, academic records. But they don't know anything about what is required in the consultancy there, what they have been working. And after I thought, later on, 2 to 3 years working there, I thought, why not impart this knowledge, what we have gained so far to others, and particularly in this field. And from 2015 onwards, I have been doing the more training, not only, there is no advertisement for that, only I will give only 5 to 8% at a time training on computer-aided design of electrical systems after the meter. I went to several colleges. I have discussed with the faculty there, whom I know through IEEE, they are my IEEE colleagues. Why don't you don't have any experience in this side of the electrical system? No, we are having, what is it? What you are having? We are having CAD. What CAD you are using? AutoCAD. So that's another grave, what shall I say, blunder, mistake, or ignorance. Many students coming out of the college make a way to make a beeline to the AutoCAD center to study AutoCAD, because they think that is the one required for after the graduation. Where did they get the idea? Who gave them idea? And many students called me. Do you teach SCADA? No, I am an old man. Sometimes even though I run a pool, I lose my temper. You know, what do you know about SCADA? And what do you do after learning SCADA? How many companies will absorb you? When somebody will say, do you teach MAP? No, you first learn E, then for the go and MNP. Without knowing electrical, how we are going to a mechanical and plumbing engineer. You know, they know something and they want to go ahead. Without knowing the basic electrical engineering design, how will they do? They want to do the design of mechanical and plumbing. They haven't studied at all. But the electrical they have studied. With some effort they can go on that way. And some students will ask me, so do you give certificates? That's another joke. I will say these colleges are issuing certificates, not knowledge. And that is what the students say also. They are happy with the certificate. The colleges are selling certificate. I will say colleges are selling certificate, not knowledge. And the students think that certificate is all what they want. I told them, certificate I can give you, no problem. I am giving. But that's not the issue. It's not a great problem for anyone. And who is bothered about the certificate? The employer is bothered about your certificate. He is bothered about the knowledge you are having, not your certificate. You can give a bunch of certificates. I know many students are having a full bundle of certificates. There are good certificates, some participating, some international events, some other events which give them some leadership qualities, etc. that are there. But they will, even if with that, they will check up with you where you have the essential skills and attitude, the competence they are aiming at. That is what is required by them, because they are giving money for you, and they want to get the result for that. So I am coming to that portion. Yeah, I was coming to that AutoCAD. AutoCAD is so okay. So some extent is useful for a mechanical student, mechanical engineer, for 3D drawing, for a civil engineer, for an architectural engineer. But all these are for making outputs of the design. First, you have to make the design. Electrical also, we have to make the design in the AutoCAD. That's okay, I understand. But that's the output. Where is the input? Then you have to make the design. Without making the design, how we are going to make the output? First you design the thing, then you translate the drawing. Then you use AutoCAD. Without knowing design, how you are going to do the design do a drawing. AutoCAD is required. I am also teaching AutoCAD. That's for the electrical engineer. The signal diagram is the one. The simplest of all those among the architectural, civil, mechanical people. The drawings in our signal diagram is the easiest way. They have their 3D drawings, the high-rise buildings, sections, etc. Slightly complicated. They require more expertise on AutoCAD, but the electrical engineer requires only very maybe 2 to 3 hours training. They can be trained to draw an AutoCAD and get a printout of that. Not a big issue. Maximum 10 hours. So that is the mistaken notion many of the faculties are having. I don't know how many of you are with me. And I have gone to different colleges and conducted training. My design has to be shown. I have been doing design on Excel. But I know many of the faculties are doing their office work, doing Excel. But they should not tell the students the benefits of Excel. They will only say math lab, high power, like that. How many of the students going out of college will be doing my power? How many of them are doing math lab? How many of them can afford math lab? But in every computer there is an Excel. Everybody is using. Every faculty is using for their office work, or for their tabulation, mark, and other things, etc. They are doing it, but they will not teach them. There is no Excel in their lab also. You don't have Excel? No. We have only Ubuntu. I don't know. I was not knowing what Ubuntu was. Then okay, I will let you open Ubuntu and see how my program will work. You will not work there. You will not work there. You can see something, but you can manage those things. Every computer is having an Excel in their field. By default, it is there. Why do you deny that? I want to share one more experience, two more experiences I had in my engineering college, in my studies. Electrical engineering, first class, the lecturer came. He was a fresher from the college, and he was introducing the class the books required after the period. One of the books he has mentioned was Parker's book. So in my enthusiasm, me and my colleague and I went to the cooperative store in the Trivandrum city. And as for Parker Smith, okay, yes, some 30, 35 rupees at that time, 1976, 60, 67, 66, 65, 66. And I bought to my hostel, opened it, full of problems. There's a saying in Malayalam, the unhusked coconut for a dog. I have been keeping it at the end of my studies. I could not do any problem on that. I know. But a couple of days before, I checked what is the status of Parker Smith in the current lab. Fortunately, there are answers for that. Now, all of you are in a good position. But that is uh, the input I gave from one of the engineers. They will not say what is best for you. And in the electronics, for my first class, that's also a professor from the college, came as a teacher. We were told the book, F.E. Terman. I went to the university library, checked for in the evening, checked for the F.E. Terman, and it was rented out. Somebody has taken that out. I booked for it, and after 2 or 3 months, I got a F.E. Terman. This much volume of F.E. Terman is prescribing for a fresher student, an electrical engineering student who is going to study. So this is the way they will not tell Excel is a good. They will say something else. And since they don't know what is AutoCAD, they will say AutoCAD. I am sorry for the critical mentioning of these things, but so what are the options for an electrical engineering graduates coming out of the college? Somebody is selected by some industries, campus selection. Somebody is going for higher studies, get selections and go to MTech or abroad or somewhere MBA like that. Some prepare for competitive examination, civil service examination, bank exam, or other examinations, get good jobs. And some are selected for non-core industries. This is I meant for the electrical engineering, mainly electrical engineering graduates. And some join core industries. And what is core industries? That's why, as I mentioned, are they equipped to meet the challenges of the industry? Some industries train them to suit their demands. But electrical consultancy and contracting is one of the areas which a fresher can straight away go and get some experience before getting another job. There are a lot of consultancies in Kerala and abroad. Because the real estate boom, the boom is there. There are not many developments are coming. Techno Park, Cyber City, like that. A lot of big city developments are coming. Some industries are also coming. So they have the options there, many options there. If you know the technique. What is the infrastructure development? This is a techno park. Infrastructure development, there will be 100-acre area, with a lot of buildings. The buildings are electrified, that's there. That's a different design. And how to feed the industries, how to feed this building. We have a lot of such things now. Previously, such developments were very few in our country. Now there are a lot of coming. Info Park, Cyber City, Science City, like a lot of things are there. This design, this is a very unique design. You have to start from the basic, how many acres of land, there's no other input. 100-acre land, you have to find what is the substation required, what is the 11 kV cable required, how much the length is required, what are the ring mains units are required. So that design is included in this one. Industrial complex. What is industry? Industry is full of motors. Motor, what is the problem with the motor? Motor has a starting current. motors capable 1 horsepower to say 300 horsepower are in there. So the starting current of these motors will be having some problems. So we have to design the system to take up the starting current of these motors, and we have to design the transformer and the generator to take up the starting current, because the motor should not stall. High-rise residential apartments. The other two are comparatively simple, I will say, but it's slightly complex. Only slightly, but this is not rocket science. I want to stress upon this one. This is not rocket science. A simple arithmetic. Maybe some equations will be there. Some electrical equations are there. The P is equal to VI. That is only the equation is required. From that we can go to other equations. No problem with that. At least that much information is required. And a simple arithmetic. The people who are joined return from the colleges without mathematical basis. I was experienced. Many students came to me. So I have to teach them the required arithmetic, the school arithmetic required for this. Then commercial complex is an extension of the high-rise residential building, healthcare facilities. That's also slightly modified, because there are patients who cannot do anything, they cannot be on their own. So we have to take care of those things. And some of their systems are short circuited, so there will not be any resistance to normal supply. So some special precaution has to be taken in this case. High-rise residential building, and now I'm taking the high-rise residential building initially. It's a complex one because two transformers are required, one for the apartment load and another for the common facilities. There will be common facilities like lift, water pump, sewage treatment plant, fire pump, and common lighting areas, yard lighting, parking lighting, basement lighting, office lighting, yard corridor lighting, terrace lighting, like that. These are in common areas. So another transformer for the common load. So there will be two transformers. We have a supply is very unreliable, so we provide a generator to make you supply to those things, lift, pump, etc., and the lights also. We have to use the generator, so we have to say the generator also, and we have to design both three-phase cables and single-phase cables. The number of single-phase cables and three-phase cables depending on the number of apartments. The length also varying from tens of meters to hundreds of meters, depending on height of the apartments. So there the voltage drop calculation comes for those apartments, for the cables of those apartments. So I assume that there is a lot. I have a plot area, say 1 acre plot area. I want to do some business. I met an architect. Say I want to build an area, building there, a residential complex there, and he has some other consultants under him, an AC consultant, a STTP consultant, and an electrical consultant, and he will be discussing with them. So we got a business, a 1 acre plot. So everyone will be doing their design based on this information. That is version number 1. Later on, the architect will say that he will work out the built-up area, 11,000 square meters are required. That's version number 2. Later on, he will come with a more specific, how many 3-bedroom apartments, how many 2-bedroom apartments, like that, how many floors. So that's version number 3. At that time, maybe I will interfere with them. Now there is a tendency for duplex apartment is more, and there is no demand for 3-bedroom apartment. Some changes has to be made. So we have made another changes, 4th version. And final version, he will be giving the actual plan. And minimum 5 to 6 versions will be there. So you have to make a design, 5 to 6, make revisions for 5 to 6 times. So that is another if you are designing a system so that the modification is easy, then it is very good. Otherwise, you have to repeat the whole thing 5 to 6 times. In one of my very wonderful experience, I have done 18 versions. Very wonderful experience. So final version was modified, but there will be minimum every design will be having 6 versions. So revision, several revisions of design is one item. And as I mentioned, large number of cables, 3-phase cables and single-phase cables. Number varies, length varies from tens of meters to hundreds of meters. So for that, you have to calculate the voltage length. Although if there are 100 apartments, you have to calculate the voltage drop of 100 3-phase cables, 100 single-phase cables. And if you have to make the revision 6 times, you have to do the revision for 6 times. So that's a very tedious job. That's why we are resorting to computer. In the electrical system design, there is a topic in the final year electrical system. Nothing is mentioned about computer. And they think a single-story building, the electrical design is good for designing a high-rise residential. Recently, I have conducted 3 workshops in this field, online workshops. One by Marine Engineering College, second by Sribusa College, third by St. Joseph Pala. 50 to 100 participants from different parts of the country, both students and faculty members were interested in that. And I shared with those things. This thing. I don't know how many of you are attended those programs. And this is the most effective program, most available program. Effectiveness also is there. Availability is also there. Every computer will be there. Excel, you can use it. Very, very powerful program, very powerful application. Excel is a very powerful application. A lot of functions, 565 functions are there. Only at least if you are using 5% of the functions, you can do wonders. Even those things are useful for postgraduate students or even master's students. Those programs can be used. Very lot of functions. You can do wonders on that. With this one, the design can be done very easily. Any number of floors, any number of apartments, a residential area can be done within 2.5 hours. The modification requires only 5 to 10 minutes. There are some formulas, maybe 25 formulas there. You check up the formula, you modify the formula, or you are putting the parameters. You change the parameters, everything will be changed. So that's why modification can be done. Error checking. We'll check up the 20 equations, 20 formulas. If there are any problem in the formula, or if there are problem in the data, you check up only that. So another 10 to 15 minutes. And there will be some supervisor. You can easily check it. Ease of verification. Verification is also easy. And scalable also. That's what I said. Any number of floors can be done. If there are 100 floors, you copy 100 times. First you do the first floor design. Then you copy 100 times, you are getting 100 floors. If you are copying 200 times, you are getting 200 floors. That's all. That's it. The scalability is there. So very easy job. You can achieve this one using Excel. It's a modular and structured. Everything is done in modules. So first you prepare the loads, then you prepare the breaker and cable, then you prepare the transformer, then you prepare the common load, then you prepare the generator. So there are different modules, or the interlinked, or the structured. Any change in one module will be reflected in the other. Some final calculation of the right modification of the transformer specific capacity or generator capacity only to be done. Other things will be already automatically done that there. It's taken care of in the program. Excel has some very good features for that. We are using very few advanced commands for reconstruction, very few. And parametrical method of design is done. The variables are made as a parameter. Variables are made as a parameter. You change the parameter, it will automatically taken care of in all the sheets. So parametric, modular, and structural method of design. Less time for design, less time for revision modification, verification, error checking very easy, and scalable. Scalability is the beauty of this application. Only these functions are used. Lookup function. There is a VLOOKUP, there is a HLOOKUP, vertical lookup and HLOOKUp. There is a concatenate function. Most of you know concatenate. You might have learned in your programming languages how to join the text. And if function, that also you have studied in your programming, right? Some count, or most of them are still used, maybe are still using that. So high-rise residential building. So there is a power factor compensation is required. You have to improve the power factor from 0.85 to 0.95. There are some benefits are there. Copper loss reduced, capacitor equipment reduced, voltage drop regulation improved. Like that, there are 5 benefits out of these things. You can achieve those things. And moreover, if it is a high tension consumer, your energy is also, your cost of power energy is also saved, not a cost of energy. The demand cost is also reduced. So for improving power factor 0.85 to 0.95, this can be simply derived from this one. 0.291 kVAr is to be added to improve the power factor from 0.85 to 0.95 for 1 kW. For 1 kW, improving power factor from 0.85 to 0.95, you have to add 0.291 kVAr. So if you are 100 kVAr, 100 kW is a load, 100 into 0.291, 29 kVAr is going to be added to improve the power factor. That's all. Now this is a load design. I take the largest room, 4-bedroom apartment, install rooms, install the electrical system there, down like tube light, wall lamp, ceiling fan, exhaust fan, like that, AC, geyser, all that. Put the water there, and room wise how many points are there, sum it up, and find the total wattage for each total load for the 4-bedroom apartment. Remove the 3rd bedroom, remove the 3rd toilet, it will be a 3-bedroom apartment. Remove the remove the 4th bedroom and 4th toilet, it will be 3rd bedroom apartment. Remove the 3rd bedroom and 3rd toilet, it will be a 2-bedroom apartment. Remove the 2nd bedroom and 2nd toilet, it will be a single-bedroom apartment. It will automatically be calculated. Within 5 to 6 minutes, this load calculation may be done. And this is we prepare the chart for this one. This is the vertical table, vertical lookup table. Looking at these 4, 3, double, single, 4-bedroom, 3-bedroom, double bedroom, single bedroom. 4-bedroom, 25.4 kW, 3-bedroom, 21.4 kW, double bedroom, 17.45 kW, single bedroom, 13.48 kW. You can use the VLOOKUP to put this value over here. So this makes it, you just write one formula, just copy it. You have already copied that. If there is any change in the previous sheet, say if this is not 10 watt, it's only a 15 watt, you change the 15, it will be reflected here, it will be reflected here, it will be reflected here. That's the linkage comes. So you find out the kW, you find out the current, you find out the breaker capacity, like that. This also can be taken from a table. You need not put it, you need not input it. So if you copy this one, it can be copied to 100 floors. So that's why the scalability achieved. Then calculation of voltage drop. You prepare the voltage drop sheet. This is the voltage drop, 3-phase voltage drop for different types of cables, 4 square 1, 6 square 1, 10 square 1 cables, and the corresponding breakers. And you prepare an if formula, only one formula you write. There may be a nested formula with total 3 ifs. You will get a simple formula, and the voltage drop is calculated, any number of floors. So I will say, theoretically, infinite number of floors can be calculated using that formula. So this is the final here 10 square mm, 54 meter length, like that. It comes like that. So you have to calculate the total connector load or the capacity of transformer. The common panels, the lift panel. So some this design is slightly different from the other design. Here you have to take care of the starting current of the biggest motor and do the design of the motor. So you do the income like that. So what the pump design, the light design. So the common lights are design, common loads are design. The common load transformer is design, and combining these two, you can get the generator load. How much is the capacity of a generator from the apartment, and how much is the total common load is required. So you design generator. So I just mentioned the only the skeleton things. This can be achieved. This can be done very easily. Not a big job. But just give them some introduction, and the student will pick up from there, and they will get the employability will really improve. That's it. You can just go there and say, I can. You give me some job, I can do the design without anybody's help, and get that important job and prepare the design and draw the AutoCAD drawing and give it. This job is finished. So I am giving them training on A to Z of the consultancy job, from load preparation to all those things. Finally, the tender document preparation. So they get this one. That's it. This is a very simple thing. It's not a. This is where I made the anecdote from Valiyattai. There is no multi-degree differential equations involved here. Some arithmetical formula and some rules. There will be some rules that has been combined by the electric inspector. That is also available there. Electric inspector publish a diary containing these rules every year. Pay 300 rupees, 400 rupees. You can have it. You can. I think every electrical engineer should have a copy of this one. I consider it as a what shall I say, Bible of electrical engineering design. Everything is there. The design is made simple. They have all the tables and rules are mentioned there. You take the tables, use it, take the rules, employ it, complete the design. If anybody is not familiar with that, you can do. At least in Kerala, I don't know. In other states also, there will be similar things. I don't know. I'm not sure. In abroad, you can start this with this one, and if anybody wants a more detailed one, you can work it out and give it to them. So you know the basic things. The industrial complex. So motors. There are 35 motors, varying from 150 horsepower to 2 horsepower, made in groups. Which means one room has some motors, some other motors. Take that group. That will be one panel will be feeding those groups. So start with the smallest one. Before that, do the total connector load, do the transformer design, the generator design, then do the design of these motors starting from the smallest one. Transformer design, APFC design, generator design, the motor design here, as done in the previous case of the high-rise building, lift motor, etc. So this can also be automated. There are some tables available in those books. You take the table from here, using some VLOOKUP functions, and that can be automatically done. You write only one equation. You could just copy it. Everything will be solved. Like that, then combining different groups to suit them. There are some rules. If there is an ACB is coming, the outgoing should be a minimum 1/3. If there an MCCB is coming, outgoing should be 1/5. So those rules are there. To match those rules, you make the modification, do the final design. That's all. Finally, you get the final main switchboard design, other switchboards like that. That's what this is not a rocket science, a simple thing. When you attempt that, you can do it very well. You can share it with your students, give it to them, and their they are benefited. Their employability is improved. You can improve that those this stubborn employability standard can be improved. Similarly, infrastructure details development. So some more formula has to be discussed. It will take some more time. I will take some questions. If time permits, I will come back to this one. Otherwise, I will not be able to. This is slightly varied, but as I mentioned earlier, only the information you got is the acre of the land, 100-acre land. No other information. You have to design the EHV substation and the cables, 11 kV cables. That's the beauty of this thing. Thank you for the patient listening. There are 116 participants. Thank you all for listening to me patiently, and you can give me your feedback. I'm sorry to say, sorry to be blunt in some times. If it offended somebody, it was not meant for that. I wanted to be state some facts, because we are facing those facts in the country. Some thoughts can be shared. That's what I meant. Okay. Any questions?
Sir, we don't have any questions for the time being.
Okay.
So
Okay. Then shall I go back there and show it there, or shall I finish it? 42.
So
Or 50, 10 more minutes. I will just show it to them how the industry is designed.
Yes, sir. Yes, sir. Sure, sir.
So this is one basic requirement of the electricity board. Depending on the load, what's the voltage? I think an electrical engineer should be familiar with this thing. In your home also, if your net connected load is maximum connected is 5 kW, you will be having a single phase connection. If your maximum connected load is 100 kVA or less, you can have a 3-phase connection. More than 100 kVA is the maximum contact demand. Contact demand is the maximum demand. You are now entering into a contract with the electricity board, so that my maximum demand is so much. I want supply. That's called maximum contact demand. Depending on your maximum contact demand, your voltage is fixed. 100 kVA, less than 3 MVA is 11 kV, less than 6 MVA 22 kV, less than 22 kV 12 MVA it is 33 kV, less than 20 MVA it is 66 kV, less than 40 MVA 110 kV, and more than 40 MVA is 220 kV. You fix up the area, take up the maximum demand, then you can see what is the total capacity. This is the basis of the table. That design is based on this table. I have derived a formula. I will just show you the final result. The house, let's say house. House is connected from a pillar. This is similar to our connection. Here we are getting the connection from the top of the pole. Instead of this, that's a very crude way of electric distribution. Normally there will be a feeder pillar on the place of the road. The cable will be going there. From the cable, the feeder pillar is fed, and from the each houses are fed. You know the total connected load of each house. Assuming some different demand factor, you can work it out and find out the maximum demand of the feeder pillar. Then they say, from this you can work out the maximum demand of the LT line. From this you can work out the maximum demand of the transformer line. Transformer. From this there will be many transformers, and coming from an 11 kV line, they say then the maximum demand of the 11 kV line can be worked out from this thing, and finally the maximum demand of the 110 kV substation can be worked out. The final formula will be maximum demand of the 110 kV substation will be the total connected load coming in this under substation. Then demand factor, the lowest part, the house, demand factor of the house, and the coincidence factor of the house. I will say what is coincidence factor later. Coincidence factor of the house, then coincidence factor of feeder pillar, then coincidence factor of the LT line, then coincidence factor of the 11 transformer, then comes the coincidence factor of 11 kV line. So there are, for designing a ESP substation, there will be 1, 2, 3, 6 functions, product of 6 factors, starting from the demand factor of the houses and coincidence factor of the houses. Coincidence factor means you must be knowing what is the diversity factor. Coincidence factor is the inverse of that. Diversity factor is the sigma of the non-coincidental load divided by coincidental load. That is the diversity factor. It is the inverse of that. That's all. That's all. If you know the houses load, if you find out this one, you multiply this one by that factor. That's all. Every way you multiply that one, you will get the final. So that's how it is done. So this is the 11 kV system, ring main system. Very advantageous. The ring main is used. 11 kV. This is a 11 kV bus of a 110 kV or a 60 kV substation. From 11 kV feeders are coming and connected into rings. This has a very high security of power. The loss of and reliability is improved. The failure will be maybe 2 to 3 seconds to maybe a few minutes, depending on how you manage those things. If you can manage those whole thing from your substation, the remote control is there, then the failure is only for a couple of seconds. If it is there is no remote control, somebody has to go there by scooter or bike, switch on those things, then it will say 5 to 10 minutes. So the supply can be restored. That's the beauty of this ring main system. And another thing is the cable of the design. That's what point I want to stress upon here. The cable is designed to be sent not to the feeder, but the ring. This ring. It's a ring configuration, but radial feeding. One of the breaker, either this breaker or this breaker is open. So this will be, these 3 army will be fed from army means ring main units fed from this feeder 5. These 3 will be fed from the feeder 6 like that. If this cable is fed, gone out, then you can switch on this one, keep the feeding like this. So that's why this cable should have the capacity of the ring and not the feeder. So that's the thing which I have to impress upon. The different plots, total 30 acres, 3 plus acres has gone for the roads. This is not a fictitious design, it's a real design. The real design. And the built-up area is found out. Built-up area is equal to, this is a floor area ratio. Floor area is the ratio of the built-up area by plot area. You will get the 2.5 for quantum. If you search or you go to the local body, you will get the floor area ratio or floor space index. One is a ratio, as an index. So both are same. One is given as a percentage, as given as a ratio. Built-up area by plot area. Plot area by plot area multiplied by 2.5 the FIR, you will get the built-up area. Once you know built-up area, this is the load power density. This is a slightly old value, but still you can use it. An authority value. National Building Code provides this value. Initial design can be started this one. Final fine tuning can be done when the actual load comes. We put the actual load as we have done in the downlight, tube, fan, the ceiling fan, exhaust fan. So 5 ampere socket, 16 ampere socket, like that. So put it like that, it will be modified. So without any data, you can start with this one. Then total connected load worked out, maximum demand worked out. The formula is maximum demand is equal to total connected load into demand factor. Assume a demand factor. Design is always based on prudent assumptions. You have to make some assumption. Demand factor is 0.8. That's a prudent assumption. Nobody will complain you why you assume. So this is industry standard. Similarly, the final power factor, initial power factor you can assume as 0.85. That's also an assumption. Final power factor can be assumed as 0.95. That's also an assumption like that. Sorry. So like that, you can go step by step, multiplying.
Sir, you are not audible, sir. Sir, you are not audible, sir.
Is it okay now?
Yes, sir.
Sorry. I think you heard this one. Only after that, the load power density, light load 20 watt per second. Small power means sockets, 5 ampere, 16 ampere socket, 30 watt per second. No, 20 watt per square meter. Small power 30 watt per square meter. For a technical building, there will be more. Technical building means there will be more sockets, like a computer building, labs. Those can be kept as there will be a lot of sockets coming, other than the residential building and an office. So that is a technical building. 41 watt per square meter is the small power, and AC is 100 watts. So actually, this is small, light and small power. This is not small power. This is light and small power. This is also light and small power. For AC, technical building, the load will be 141 watt per square meter. That is the basis. You can start with that. Then find out the demand factor, and find out the maximum demand of the total connected load into demand factor. Demand factor is assumed as 0.8. It's a prudent definition, assumption. And power factor also can be defined as 0.95. We are improving the power factor from 0.85 to 0.95. Beyond improving in the 0.95, it is not economic. You have to add more capacities from 0.95 unity. So you will be improving the power factor up to 0.95. So you need only add capacitor to from 0.85 to 0.95, like that. Then transformer is designed. Then each a group of transformers may be coming out of the plot. There is only an RMU. RMU is feeding either one transformer, two transformers, or a group of transformers. The RMU is connected. If you know the maximum demand of the plot, you can multiply the maximum demand by the coincidence factor of the plot or building, then you will get the maximum demand is RMU. And the RMU is connected to the cable. This is an RMU. This is an RMU, which is 4 transformers connected. RMU, this cable is coming here. There's a breaker here. There's another breaker here. And going abroad. And this is a switch. You can open the switch and then this will be isolated. Like the road can be isolated. So this is now in vogue in our countries also. In Trivandrum, it has come in large numbers. Many cities also coming. So as I mentioned earlier, the reliability can be improved using the ring main systems. And this is the design of the cable. I'm not going into much details about this thing. The cable can be designed. 5 cables touching, 4 cables touching, 3 cables touching, 2 cables touching. What is the final capacity? Now I am considering 4.53 is the depending on the previous sheet. The maximum demand of the RMU is maximum is 4.334. You cannot have a cable smaller capacity. Minimum this must be the capacity. Then you can have one cable with one RMU, one ring with one RMU, like that. So that's why I have taken this 4 cables touching. This is 400 square mm copper 3-core cable, an armored cable, XLP cable, which has a capacity of 4.53 MVA under the conditions. Ground temperature 40 degrees centigrade, depth of laying 1 meter, soil resistance 1.5 Kelvin meter per watt, and four cables are laid in one corridor touching, like that. Then you can group it the RMUs. How many RMUs are coming in one ring, like that. Here, only one RMU. In these three cases, only one RMU. That's one ring. Ring 1, one RMU. Ring 2, one RMU. Ring 3, one RMU. Because those loads are high. In ring 4, these two loads are combined and then multiply by the coincidence factor of the previous, the transformer. Then you got the RM, MD of the RM ring, like that. Once you know the MD of the ring, then you can work out the maximum demand of substation. Some of these things multiply by the coincidence factor of the ring, and you will get the capacity of substation. Once you know the capacity of substation, then you can decide 21.348 means is more than 20 MVA, say 110 kV substation. So what is the transformer capacity? It is a 110 kV substation, 3 into 12 MVA. You can have a 2 into 12 MVA, but have more redundancy. You are providing one more transformer, 3 into 12 MVA. Okay. Is the final capacity, final say 60 kV by 110 kV by 11 kV. So that's the design of the final design. Skill is the unified force of experience, intellect, and passion in their operation. Achieve skill and thrive in life. Thank you very much. Thank you very much for the patient hearing.
Thank you, sir. Thank you, sir, for your powerful message. We are charmed by your sharp eloquence. Sir has emphasized the need for student industry exposure so that the institutions can make sure that their goals set as PEO are achieved. He stressed that the need of the hour is industrial association in engineering colleges for bringing out skilled engineers. Sir has expressed wholehearted genuine opinions and suggestions to bring up a skilled engineer to increase academic performance index, and he enforced on the need for issuing guidelines for students on internship, and these career-oriented internships should start from first year. Thank you, sir, once again, as the participants have posted their genuine feedback for your genuine talk. Thank you, sir.
Thank you very much. Once again, I thank the organizers, the AICTE, Professor Teres in particular, the organizing committee, the college management, and the faculty of the college. Once again, thanks from my bottom of my heart very much, Professor Teresa, once again.
Thank you very much, sir.
And wish you all the best
Thank you.
in your future endeavor. Make it bright. All the best to you.
Okay, sir. Yes.
Participants can fill in the attendance form and the feedback, and you can rejoin for the next session at 2 p.m. Thank you.
Okay, shall I leave?
Yes,
So
sir.
you can leave
Yes,
now.
sir. Thank you, sir.
Oh, the